The work of Nobel Prize has transformed our understanding of the world. While approaching the Nobel Prize winners in chemistry, we not only learn their achievements, but also the spirit of honesty, tenacity, innovation, and forging ahead. Hello everyone, welcome to today's class, the Nobel Prize winner in chemistry. 同学们，你们好，欢迎走进今天的课堂，化学诺贝尔奖得主。今天给大家介绍的是弗里茨·哈勃。For today's class, I will introduce you a scientist who is Fritz Haber. People consider him as the incarnation of angels and devils. In the history of chemistry, there's a chemist who has long been sleeping underground. But he has left the world a heated debate about his merits and demerits. He was Fritz Haber, a world-famous German physical chemist and inventor of synthetic ammonia in the early 20th century. The man who praised Haber said he's an angel, bringing harvest and joy to mankind, and a saint who bakes bread with air. Those who curse him said he is devil, bringing disaster, pain, and death to mankind. Fritz Haber won the Nobel Prize in Chemistry in 1918 for the synthesis of ammonia from its elements. He worked at the Wilhelm Institute, now it's called Fritz Haber Institute, for physical chemistry and electrochemistry in Germany. One of the most important plant fertilizers is nitrogen. Air is mostly nitrogen, but plants can only use nitrogen when it's part of the chemical compounds. In about 1913, Fritz Haber developed a method for producing ammonia from nitrogen and hydrogen, which could be used to make artificial fertilizer. When nitrogen and hydrogen gases pass through a device that at a controlled temperature, pressure, and flow rate, a catalysis, ammonia is formed in an energy-efficient process. In 1905, he published his book on the thermodynamics of technical gas reaction, in which he recorded the production of small amounts of ammonia from nitrogen and hydrogen at a temperature of 1,000 degrees with the help of iron as the catalyst. Later, he decided to attempt the synthesis of ammonia. He accomplished this after searches of suitable catalysts by circulating nitrogen and hydrogen over the catalysis at a pressure of 150 and 200 atmospheres at 500 degrees temperatures. This resulted in the establishment of opal and lemon ammonia, which enables Germany to prolong the First War, and his supplies of nitrites for making explosive had failed. Modification of this Haber process also provided ammonium sulfate for using as a fertilizer for the soil. The principle used for this process in the development of the control of catalytic reactions at high pressures and temperatures. It led to the synthesis of methyl alcohol, to the hydrogenation of coal, and the production of nitric acid. Why his work was so significant? Let's hear what he said. The synthesis of ammonia from the elements is a result which physical chemistry was bound to reach. The solution to the problem which has been found assumes its importance from the fact that very high temperature levels are not employed. And that makes the ratio of coal consumption of nitrogen production more favorable than is the case of other processes. Results are enough to show that, in combination with other methods of nitrogen fixation, which I have mentioned, They relieve us of future worries caused by the exhaustion of saltpeter deposits that has been threatening us 20 years. Nitrogen bacteria teaches us about nature. With his sophisticated forms of the chemistry of living matter, still understands and utilizes methods which we don't know yet how to imitate. That sufficed in the meantime improve nitrogen fertilization of the soil, brings new nutritive riches to mankind. And what the chemical industry comes from the age of the farmer, who in good earth changed stones in bread. Let me briefly introduce you how to synthesize ammonia. Since the beginning of this century, the global crop yield per unit area has been increasing. Depending on a certain extent to the increasing use of nitrogen fertilizer, nitrogen content in atmosphere is close to 80%. But this nitrogen cannot be directly absorbed and utilized by higher plants. The prospects of artificial nitrogen fixation are endless. This will greatly increase the food production in developing countries. It will be good news for mankind. Ammonia is one of the important inorganic chemicals products, which occupies an important position in the national economy. About 80% ammonia is used to produce chemical fertilizer and 20% is the raw material of other chemical products. Ammonia is mainly used to produce nitrogen fertilizer and compound fertilizer. The mechanism of ammonia synthesis reaction is that nitrogen molecules are chemically absorbed on the surface of iron catalyst, which weakens the chemical bond between nitrogen atoms. Then the chemical absorbed hydrogen atoms continuously interact with the nitrogen molecules on the surface of the catalysis, and gradually from NH2 and ammonia on the catalysis surface. Finally, ammonia molecules are dissolved on the surface to form gaseous ammonia. When the First War broke out, Haber was appointed as the consultant to the German War Office and organized gas attacks and defenses against them. He helped to create the German Relief Organization and served on the League National Committee on Chemical Warfare. His laboratory became an important military institution serving in the war. Haber undertook the supply and development of materials needed for war, especially in the development of war gases. He mistakenly believed that the poisonous gas attack was a good way to end the war and shorten the time of the war, thus serving as the scientific director of Germany's poisonous gas war during the war. That's the story for Fritz Haber. How do you think about him? Is he an angel or devil? Thanks for watching.
大家好，在化学发展史上，有一位化学家，虽然他已长眠地下，但是他却给世人留下关于他功过是非的激烈争论。他就是20世纪初闻名世界的德国物理化学家、合成氨的发明者弗里茨·哈勃。赞扬哈勃的人说，他是天使，为人类带来丰收和喜悦，是用空气制造面包的圣人。诅咒他的人则说，他是魔鬼，给人类带来灾难、痛苦和死亡。针锋相对、截然不同的评价，同指一人而言，令人愕然。1918年，瑞典皇家科学院因哈勃在合成氨发明上的杰出贡献，决定授予他诺贝尔化学奖。但因哈勃在研制化学武器上给人类带来灾难的行为，世界许多科学家提出异议。对于带来的灾难， 哈勃辩称自己迫不得已。最终，哈勃仍然因其对人类的特殊贡献而获此殊荣。得奖后，哈勃将全部奖金捐献给了慈善组织，以表达自己内心的愧疚。回顾化学发展过程，化学史上每一个重大的化学成就都是在一定的社会背景条件下产生。一项重大的科技发明历来就是一把锋利的双刃剑，在给人类带来福音和实惠的同时，也带来了不幸和灾难。合成氨的发明同样如此。金无足赤，人无完人。哈勃的故事会一直传播下去，功过是非任人评说。好了，本次课到此结束，谢谢大家，再见。